Okay, so here's the second part for section 4.2. And again, we're dealing with trigonometry, so that's sine, cosine, tan. Some more complex situations like where there's more than one triangle and we have to solve in different steps, right? That's what we've been doing. This one is working with triangles in 3 dimensions now. So before, we've been doing stuff like this where we have a triangle, a right triangle here, and then maybe another right triangle here, right? And we've been dealing with this sort of thing and finding little pieces as we go along. This has always been in 2 dimensions, sort of like just on the page length and width. Now we're talking about, visualizing 3-dimensional objects. And so this is a perfect example of one of the more complex type questions that you'll encounter. So let's see. Do I have a little box here? I don't think I have a little box here. Let me see. Do I have something in the shape of a little box? Okay. So I have this stack of papers here. It's like a little calendar thing. But this is roughly, if you ignore the coils, that is a rectangular prism. Okay, it's kind of like a box. Now think about this as being an open box, and you've got something that you open up the top, and then you put inside, like this pen, and you put this inside. Now the question here is saying, what is the largest pen that you could put from this corner all the way through the middle to the top corner? And that's kind of what they've tried to draw there for you. So if we look at this, here's a rod that fits in a box, and what is the longest rod that you can fit in there? They give you some details about the box, but what you have to understand is that let's say this is the length 15 and the width is 12. This triangle right here is along the bottom side of the box, right? And so it would be kind of like, if this was my box, it would be like the 15 here and then 12 here. So that's on this plane, okay, the flat bottom plane. The question actually asks about this rod, which is in a different plane. Now when I say a different plane, I mean a different sort of slice of 3-dimensional space. So the bottom is on this flat horizontal slice or plane. The diagonal is sort of on this plane, like this. It's sort of more of an up and down. So that's why it's a little bit more complex, because we're dealing with 3 dimensions. So I'm trying to draw, let's see, I'll try and draw these 2 triangles, and I'll try and do this so that you can kind of see. So you see how this is sort of the flat one on the bottom side, and then another triangle here is sort of up and down with the rod as the hypotenuse. Do you see that? So there's our second triangle, and they are sort of perpendicular to each other. They kind of form a bit of an L shape when they meet. Okay. All right. So what we want to do, and you have the worked out solution there, so let me just walk you through it. What we want to do first is we'd want to take a look at this first triangle right here and find this D part. Okay? So we have 15, we have 12, we have D. We could use Pythagoras' theorem, right? A squared plus B squared equals C squared, and this C is actually a D, so it's A squared plus B squared equals D squared. And we could find this. Once we find D, and they've done that for you there, it's 19.2. Once we find D, you can fill that in your diagram, 9.2. And then all of a sudden, you have, I'll draw this triangle with the rod. Okay, you have another triangle that you have some dimensions for. This is 10, you see, right here. And now you have this bottom side is 19.2. See that? So now we want to find the hypotenuse. It doesn't matter if this triangle is kind of facing you or on an angle or totally on its side. It doesn't matter. Still, just a right triangle. And so we want to find L now. And now, okay, and then the second question, so we do want to find L. The second question then is, what is this angle? Okay? And so we could actually do that before even finding L. How could we find this angle, theta, right here, right now? How would I do that, given that information right there?
Could you do that 90 minus?
No, you can't do 90 minus, because you don't know this one, and you don't know this one. You guys know?
Oh.
You don't need a trig function
Yes,
to do
the
it.
second function.
Could you use a trig function?
Yeah.
Okay, you have this side and you have this side. How are those sides right there related to the angle? What is this side compared to the angle? This one, the number 10.
Oh, opposite.
From this angle, it's straight across, it's opposite. What is this this side compared to the angle? Hypotenuse is over here. This is the adjacent side. So which trig function could we use that relates opposite and adjacent? OA. Which one's OA? Tangent. Very good. So tan of theta equals 10 over 19.2. Do you remember how to find the angle? What do?
You divide both numbers and use the second function.
Okay, so you use the second function for tan, that's right. So when you use tan to the negative 1, this is really what you're doing, right? You're eliminating the tan on this side, and theta then equals tan to the negative 1. That's like second function of whatever this ratio is, right? So that's how you find the angle. And I'll just do that for you real quick over here. Oh, let's get out of that. We're doing some grade 12 stuff. So second function tan of 10 divided by 19.2. Just put that in the brackets. You don't have to do any extra work. Should be about 27.5 degrees. Okay? So you can find that angle before you even find L if you want. And L, of course, Pythagorean theorem. Okay? Any questions about that? All right. So let's move on to build your skills. Let's take a look at this. And I will help you get the diagram for this one. And then I'll see if you guys can take it away and use the skills that you guys have to solve. So an airplane is flying 100 kilometers north and 185 kilometers west of an airport. It is flying at a height of 7 kilometers. Okay, so what is the straight line distance to the airport? This one is confusing, but think about this. Triangles in different dimensions. Okay? Triangles in different dimensions. That's what this one's about. So an airplane is flying 100 kilometers north. So what I would tend to do is to say, okay, let's go north is straight up. Because, you know, like on the directions on a map, north, east, south, west. So let's make this 100. That's 100, straight north of the airport. And it's also 185 kilometers west of the airport. So that actually is this way. Now my scale is going to be a bit off here. So I might just do this, 100 and 185. Just so we have, just we're a little bit, draw it a little bit more to scale. Okay. Now these, the north, east, south, and west on a map are all at perfect 90-degree angles to each other, right? So by doing this, north and then west, we actually are making a 90-degree angle. You cool with that? So we have a right triangle here. Now, it also says that the plane is flying. Now this is where the diagram gets a bit tricky, okay? The plane is flying at a height of 7 kilometers. So if this is the triangle that's on the ground, the plane is above the ground. So we have to draw, now again, how you do this is up to you. I'm going to draw this on a bit of an angle, and I'm going to make this 7. Here's the plane right here. I don't know which way it's going, but I'll draw it going this way. Okay? There's the plane. It's 7 kilometers up in the air. So this 185 and 100 is on the ground. The 7 is up in the air. Now that might not look really good, but we're talking about the straight line distance to the airport from the plane. So maybe this will help. So this straight line distance right here, if I can draw a straight line here, that's pretty tough. You see? Now this is a 90-degree angle from the airplane to the ground. So it might be a little tough to envision that, but let me just grab a couple triangular rulers here. All right. So let's see if I can do this here. So for you guys, it looks like this. Okay. So there's the first one. This one right here is this triangle right here. Okay. And the plane is it's from here. It's 7 kilometers up. So I need another one that looks like this. Where are you? Wait for it. I'm going to find just the right one here. I've got lots of these things. Here we go. Okay, so here we got this now, and we're going to go kind of like this. You see? I've got now two triangles, and the plane is up in the air. See? So now I flip this around. There's the ground, and here's the plane up here, up in the air. And so these two triangles are perpendicular to each other. You see that? You can see that. So they are perpendicular to each other. So again, kind of like this. There's the ground, and here's the plane one. So that's what I was trying to draw there. Okay? That's what I'm trying to draw. All right. So, what's the straight line distance? Okay. We have 7, but I don't have this line. What I'm trying to find, I don't have this line. So I can find this one, because it's the hypotenuse for this triangle. Does everyone see that? So I'll solve that triangle first. And how do I find the third side of a right triangle? Yeah, Pythagorean. So there's 100, there's 185. I'm trying to find this guy. So 100 squared plus 185 squared equals my unknown side squared. If I take the square root of both sides, I get my unknown side. So hopefully you're getting fairly good at this now.
My calculator doesn't do it like that.
Well, what do you mean? Do it like what? You can do it like this probably.
No, it won't.
Yeah, it will.
No, it won't.
100 squared plus 185 squared. I'm going to take the square root of that. It's 210. Now what you might have to do is you might have to do the inside first and then take the square root of the answer. That's fine.
That all got two. Oh.
Yeah, it did do it, huh? Wah. Okay, so 210.23, let's say. Okay, 2 decimal places, right? If we're ever in doubt. 210.23, it's okay. 210.23, all right. So now I have two sides of a right triangle, and I can find the third one. So here is the one the question's all about. So I could just do Pythagoras again. There's no angles involved here. You know, we're just given distances, so you can solve this one by Pythagoras again. So I'll draw that triangle out. So here's this 7, height above the airport, and here is 210.23 kilometers away from the airport, and I can now solve this hypotenuse. And so that one is, I'm going to do the work here below, but 7 squared plus 210.23 squared equals, and this is,
Got 210.34.
sorry?
Got 210.34.
And you got 210.34? Okay, yeah, could be. I think I said it could be. So A actually equals the square root here of, square root of 7 squared, which we know is 49, but we'll just put 7 squared. 210.23 squared. And what is that? 210.34 or 35. 210.35. Good job. That's going to be kilometers. Yeah, it's very similar to this one, but we're only 7 units. See, 7 units up compared to 210 units long. So that triangle actually looks kind of like this. That little piece there, and then it's like this long. Right? So this hypotenuse side is virtually the same distance as the bottom side.
So like the angle would be like point.
Yes, this angle over here would be like really small, 1 degree or something. Yeah, sure. We can figure it out. Yeah, we can figure it out. It'd be pretty easy, actually.
We could.
This is opposite side. This is adjacent. So it's the second function tan of what? 7 over 210.23. 1.9. So like 2 degrees. Yeah. You're right. It's pretty small. Okay, so what is the angle now of elevation of the airplane from the from the point of view of the airport? That's what we just did. That's what we just did. Okay, so there you go. That's what we just did. you find this angle, which is super small, and second function tan of 7 divided by this bottom side. You could use other trig functions if you want to use the side we just solved over here, but there you go. Okay? So the trickiest part will be drawing the diagrams, guys, and getting an understanding of what you're looking for.
For the test, are you going to make us draw diagrams?
Yeah, probably. There'll be some diagrams given, but you'll have to draw some as well, just like these questions. Tests will be just like these questions. Just a little bit of everything. Okay? So yeah, so you do need to get into practice of drawing the diagrams. Okay? So you get to finish number 9, and then move on to practice your new skills. This is the wrap up for 4.2. So you have the rest of the class to finish the build your skills there and the practice problems for this section. Okay? So finish up to the end of 225. Actually, is that true? Let me see. Oh, there's one more question on 226. So you're going to work till the end of 226. That's your goal. Okay? You have the rest of this class, and tomorrow. Well, I'll